Am I audible to everyone? Sorry for the delay. Due to some technical problem, it was delayed. Am I audible?
Yes, sir.
Okay, thank you. Sorry for the delay. So let me start our today's session. In the last class, we have discussed the generic methods and generic classes. By using those by using those generic classes and generic methods, one can implement a most generalized code through which one can pass different types of parameters, different types of data as a parameters, and perform certain operations without changing the code itself, right? So code reuse is the major example, and as well as type safety. Type safety in the sense you need not perform or you need not write even single line of typecasting code, right? So these are all the some of the important key aspects of implementing generic methods and generic classes. Now let us see another important part is of this particular unit is wrapper classes, right? So is my screen is visible to everyone? Screen is visible or not? Any one of you? My screen is visible or not? Any one of you please respond. Oh. Now it is visible. Okay, okay, done. Right. So wrapper classes are those whose objects wraps a primitive data types within them. That means with the help of this wrapper class mechanism, one can convert a primitive data type into an object, because Java is object-oriented programming language where the operations are performed on objects only. So that is the reason sometimes it is necessary to convert your primitive data type like int, char, byte, long, all these primitive data types into objects. For example, if you are implementing a collection array list, okay, so array list will store only objects, not the primitive types, right? So that means whatever the information which you want to keep it in array list should be an object. So in that case, how do you keep integer data into the array list? Okay, so like that there are several places where we are supposed to convert our primitive data into objects. So with this wrapper class mechanism, we can implement that, right? So in the java.lang package, the Java provides a separate class for each of the primitive data types. Okay, so suppose if you have int is a primitive data type. For that, we have an equivalent wrapper class in java.lang package is called as integer. Okay, like that char is the primitive data type and character is the wrapper class for it. Okay, with the help of those classes, we can convert our primitive data into objects, right? Very soon we will see in the next slide, we will see what are the primitive data types and what are their equivalent wrapper classes. These all things we will see in the next slide. Until then, you just remember that for each and every primitive data type of the Java will have an equivalent primitive class, wrapper class for it, right? At the time of instantiation, these classes accept a primitive data type directly or in the form of string. Remember, here is another important point is except character class, remaining all the classes, all the wrapper classes accepts the information in the form of string only. Once again, I'll repeat the same. Except character class, all the remaining wrapper classes are accepting the data in the form of strings only. Okay, so when you are instantiation these objects, it can directly allow you to enter the primitive type. Okay, and wrapper classes provide a methods to convert primitive data types within them to string objects and to compare them with other objects also. Of course, we have discussed that. And using wrapper classes, we can also add primitive data types to various collection objects such as array list, hash map, etc. That means when we are implementing these things, array list and hash map, all these things, in that case, if you want to store primitive data values into those array collections objects, so in that case, you are supposed to convert it into objects. Right, now let us see what is the need of wrapper classes. Right, so the first point, as you all aware of that, they convert primitive data type into objects. Right, as I told you, array list is a collection which allow you to store only the objects rather than primitive data. Right, all the collections are, all the collection objects are, or all the collections of Java framework is defined in java.util package. Okay, so which handles all these wrapper classes also. Java.utility package handles the wrapper classes also. Right, data structures in the collection framework such as array list and vector store only objects, as I told you. So an object is needed to support synchronization in multi-threading. In the operating system, we have studied multi-threading, where the threads are supposed to be synchronized one with another. So this is also be done with the help of these objects. So serialization, very soon we are going to discuss about serialization. It is also an important aspect, which it needs to convert the objects into streams, byte streams. Right, so that means, as you all aware of that, Java is a platform independent programming language. That means you can develop the code in one platform and you can run it on another platform with the help of the bytecode. Bytecode is produced by JVM, Java Virtual Machine, okay, which accepts ordinary code and it produces the bytecode. Right, so now how we will done all these things, we will see later in this class. Okay, now, right, so these are the primitive data types which are available at Java: char, byte, short, int, long, float, double, boolean. And these are the equivalent, or not equivalent, these are the corresponding wrapper classes for all the primitive data types. Char, here you can observe the character is a wrapper class for char, like byte, short, int, long. These are all the corresponding. You can observe that always the starting letter of the class should be capital, whereas here it is small. And as I told you, except character class, all other classes are accepting information in the form of strings only. Right, so like that, total I think 8 primitive data types. These are the 8 corresponding wrapper classes for the primitive types. Right, auto boxing, automatic conversion of primitive types to objects of their corresponding wrapper class is known as auto boxing. For example, when you are converting int data into integer object, is called as auto boxing. And the reverse in the sense, integer object is going to be converted it into int data type, is called as unboxing. Right, so these two can be implemented in wrapper. So because this is the main object of the wrapper class, with this you are able to convert from objects to, sorry, primitive type data to object, and object to primitive type. Right, so these are the two important aspects here you are supposed to be understand. Right, auto boxing is conversion of primitive types to objects, unboxing is conversion of objects into primitive types. Okay, so let us see an example program how we will implement the auto boxing and as well as unboxing. Right. So this is the program for converting primitive data into objects, its equivalent object, right? That is called as auto boxing. Now here you can observe that here I was declared a variable ch of character type, and for which I was assigned a value small a, right? Now ch holds the value a, it is a primitive data type, right? And then I was created object for the wrapper class character, and the name of the object is a, for which I was assigned a primitive value, primitive data type value, right? Here ch contains an ordinary value, whereas a is the object of character wrapper class, right? Here directly as the way I was assigned an ordinary value to the variable, I was assigned a primitive type to an object, primitive type to an object, right? And this is one example, and this is array list. As I told you, array list will allow you to store only objects rather than primitive data type. So that is the reason here I was created object for the array list. The data type is, and this object is representing integer values only. It holds only integer values. So I was created an array list, and I was added array list dot add of 25, whereas 25 is an ordinary value. Okay, usually it accepts only objects, but here I was stored an ordinary value into value into the array list. And after that, I would like to print the contents array list dot get of 0, get of 0, 0 in the sense the index position. Okay, it displays the content which is present in the 0th position of the array list. Now you can observe what are the value that you have entered that was displayed. So here what we understood from all these steps is, okay, directly we can add a primitive data type value to the an object by using its corresponding wrapper class. Here I want to add integer value. For that reason, I'm using wrapper class object. Whereas here I wanted to store character value. So that is the reason I'm using character wrapper classes. And another important point is, here we did not perform any kind of typecasting mechanism here itself, right? Here we don't write any object, or we did not convert it into object, but directly we will assign it to the object. So that means the type safety is also be taken care by this wrapper class mechanism. All right. Now this is the way you can add primitive data type. You can convert the primitive data type into an object. Here the ch is going to be converted into an object a. Similarly, here the value 25 is going to be stored as an object into the array list, right? So with this, what we understood is you can convert a primitive type value into an object. Similarly, the vice versa also we will see. In a similar way, we can assign, that means by changing this in the sense, simply ch is equals to a. Ch is equal to a means ch is an ordinary variable, and a is an object. A is an object. So in such a way, we will try to execute how to assign an object to a primitive data type, and how we will retrieve those values. That is called as unboxing. We'll see another example of unboxing. Right. So this is, now you can see here I was declared an object ch, and so all of you listen once again. The absentees of today's class is 3, 9, 34, 39, 54, 70 and 83. Total 7 members are absent for today's class. Right. So this is unboxing. Unboxing in the sense assigning object to the ordinary variable. Okay. So here I has declared a character array object to the character wrapper class. For that I was assigned a value a, okay, and char a is equals to ch. Here ch is the object and a is an ordinary variable. Ordinary in the sense primitive variable. Okay, here the object value is going to be assigned to a itself. Similarly, array list integer. Here you can observe in the previous case we just store this value into array list. Now the value, actually in the last example we have printed the value of this particular location. Now here what we did is this location element is going to be assigned to the num, so that we will print the that particular value. Let us see here what we are expecting. The 24 is the value which we are stored at array list in the 0th position, and the same element is going to be assigned to num. When we are displaying the num, we are supposed to get 24 as an output. Yeah, so here we got 24 as an output. So like that you can assign any number of you can convert any number of primitive types into their corresponding wrapper classes and vice versa. Okay, we will see another example. Both wrapping and unwrapping are at a single program, because for better understanding I wrote it as two different programs. Now we will try to execute both wrapper and unwrapping. Right. So this is all of you observe the screen. This is another example of implementing wrapper classes, wrapping and unwrapping. Wrapping in the sense auto boxing, unwrapping in the sense unboxing. Right. So here initially I was converted all the primitive types into their corresponding wrapper class objects. Okay. So here you can observe that byte a is equal to 1. So that will be converted it into byte object. Here I was created a byte object for the byte wrapper class. For that I was assigned the value of a. Similarly, int integer. Here I was created wrapper class object integer for the class integer. Int obj is the object of integer wrapper class, for which I was assigned the value of int variable b. Similarly, float object, double object, and character object. Okay, so simply as the way which we assigned ordinary values to the variables, in the similar way we did the same. Okay, and we'll try to print all these values with the help by using objects, not with the variables. So byte object holds the value of byte variable, integer object holds the value of integer value, and float object holds the value of float variable which we have created C using C. Similarly, character variable E. Okay, so these all things will be displayed with the help of objects. And in the unwrapping, we have created another variable, byte variable, because in order to avoid the confusion, here I was declared another variable, byte BV. BV stands for byte variable, for which I was assigned byte object value. So whatever the value which we have stored in the previous steps, that object value will be assigned to ordinary variable. Similarly, integer variable, int variable. So these are all the primitive data type variables: float variable, double variable, character variable, CV. Okay. So for all these primitive data types, we will assign their corresponding objects, their corresponding wrapper class object. So here what happens, the character object value will be assigned to character variable. So here I would like to print the values of all these primitive data types for which we have assigned the values using wrapper class objects. So let me execute this program, whether it produces a correct output or not. So here you can observe that values of wrapper objects. In the first case, we have displayed the values using wrapper class object. So that is the reason initially byte code, byte object is 1, integer object is 10. Whatever the values that we have assigned, those will be printed. 250.5a. Okay. In the next part, we have displayed the values of these variables for which we have assigned by using wrapper class objects. So in that, again, we are also getting the same outputs. Okay. So with this, what we understood, we can convert primitive data types into objects using wrapper classes. For each and every primitive type will have their corresponding wrapper classes which are defined in java.language package. Okay. All of you understand this particular concept? If you have any queries, you can ask so that I'll continue with the next one. If you have any queries regarding wrapper classes, you can ask. Okay. Okay. Now, so another important concept is serialization and deserialization in Java. Serialization is the mechanism of converting an object into a stream, a byte stream. Is called as serialization. Okay, so you have submitted an ordinary object data to the JVM. JVM itself, it converts it into the stream. So that stream will be stored in stream buffer, and after that it will be moved to the location where you want to keep. Either it may be stored in the file, or it may be stored in the memory, or it may be stored in the database. So wherever you want to keep it, you can move it. Okay, so that is serialization. Deserialization means the object which is in the form of streaming, or it is in the form of byte code, which is available at either database or memory or the file, that will be retrieved and that need to be converted it into object. Here you can observe this diagram. Object will be converted it into byte stream, and then it will be stored into any one of the storage location. Okay, this part is called as serialization. When coming to the deserialization, whatever the information which is stored in the any one of these storage areas, okay, they are in the form of byte stream that was retrieved, and then it will be converted it into object. This is called as deserialization. What we can do with this, what is the use of this particular mechanism is, so with this mechanism only we are able to implement the platform independency. Okay, and even it is used to share, it is used to create and share the objects among a group of computers, because they can share. Okay. Now, is it visible or not? Is it visible? Now my screen is shared or not? It is still on program. Now? Okay, thank you. Right. So this is deserialization, is the reverse of the serialization process, where it converts the byte stream into object. Okay. So this is about the serialization and deserialization. We will see some of the important points regarding this serialization and deserialization, and we'll look at the implementation part of it. All right. So the serialization and deserialization process is platform independent. It means you can serialize an object in a platform and deserialize in different platform, as I told you. For serializing the object, we call the method write object method in object.output stream class. Object output stream class is the class which is used for serializing the object by using the method write object. And similarly, object.inputStream class is used for deserialization by calling the method read.object. Don't worry about it. We will see the implementation of all these two also, right? And another important point is we must have to implement the serializable interface for serializing the object. So whenever if you want to serialize an object, that means whenever if you want to convert your object into byte stream, you are supposed to implement the serializable interface. Okay, and notice that for a class to be serialized successfully, the following two conditions need to be met. One is the class must implement the java.io.serializable interface, because for serializing an object it is essential, right? And all of the fields of the class must be serializable. That means, suppose if your class consisting of 2 data members and 3 member functions, if all of them should be serializable, some of the cases it may not be possible. So in that case, what you have to do is you need to be make it as marked as a transient in the sense, for the temporary usage I am holding this particular data member or the member function. Like in such a way, you just pass some information to the compiler so that it can be marked as a transient and it allow you to serialize. Otherwise, what happens if you did not mark it? So it won't allow you to serialize your object, because either it should be all the fields should be serializable, or if any of the part is not, you should mark it as a transient. Make it, you just mark it as a temporary for the short period of time that is available here itself. In such a way, you are supposed to pass the message, right? So these are the two important conditions which are supposed to be met when we are serializing any object. Serializing means converting object into byte stream. Okay, and the method which is used, the syntax of the method which we are going to be used for serializing an object is public final void write object and object x, because this is the object which you are going to be converted it into byte stream. Throws the IO exception. This is by using this method we will serialize an object. Similarly, this is the another method for deserialization which can be implemented using, which is implemented in the object input stream class. Okay, so by calling reading object method of the object input stream class, we can deserialize an object. Okay, so very soon we will see the implementation part of these two. And okay, why do we need serialization in Java? First part is communication. Communication in the sense, with the help of serialization, you can share your object to the various other systems which are present in it, even though they are operating in different operating systems. Similarly, catching. So the time consumed in building an object is more compared to the time required for deserializing. So it is what it says is it takes a lot of time for creation of the new object at the new place, because you are running at one operating system and you have created, okay, and some other system is running with some other operating system. There, if you want to create similar kind of object which you have created previously, will take more amount of time rather than simply downloading it from the storage area. The storage area in the sense, the first object need to be serialized and it was stored in some storage area. Okay, getting the object from that storage area, that means byte stream, retrieving the byte stream from the storage area and convert it into object will take less amount of time rather than the creation, right? So because the cache memory will maintain some information regarding these gained objects, right? So and another important point is deep copy, that means cloning. Just simply can imagine the Xerox of it originally. Okay, cloning process is made simple by using serialization, because any number of replicas in the sense the same copy can be created without any zero efforts, right? So you can maintain any number of objects of similar type. And cross JVM synchronization, as I told you, platform independency, right? So different JVMs are running at different platforms, still you are able to execute this object in all the different platforms also. And last, persistence. So the state of any object can be directly stored by applying serialization onto it and stored in a database so that it can be retrieved later. So you can store your object after converting it into byte stream in a persistent storage area. Okay, so these are the some of the essentials that leads us to implement the serialization in Java. Okay, so these are the as we have already discussed all these things. A Java object is serializable if and only if its class or any of its parents class implement either java.io.serializable interface. Okay, any one of either this class or the parent of this class should implement the java.io.serializable. Otherwise, it won't allow you to serialize an object. Okay, so this is a fundamental information regarding serialization and deserialization. Now let us see how to implement this serialization and deserialization. So all of you observe this. This is the code for serializing an object. As I told you, everybody should implement the serializable interface. Here I was declared a class employee which implements serializable interface, which is available at the java.io.serializable. Okay, and here just I have three different data members and one constructor. My class contains only three different data members and one constructor. Don't worry about the definition of the class. Whatever the requirement or whatever the class you want to define, you can define it. No issue. So here our intention is we need to write this statement which is essential. And after that, how do we convert it into byte stream? That is also an important point. Here I wrote in the main program, employee EMP1 has created new object with the values 2000, 100. These are the values which we are storing at the objects. Okay, and by using file output stream object, output stream, because from this we are trying to store it into somewhere. So that is the reason with the help of this output stream object, we'll store the elements into the output.txt. Even you can check it out whether it is correct or not, whether the data is successfully stored in the output.txt or not. Also, you can check it out, no issue. And after that, as I told you, object.output stream class contains the write object method. So with that only we can serialize the data. So for that purpose, I has created object for the object output stream out and out dot write object of first emp1. That means this object is going to be converted it into byte stream first, and it after converting it into byte stream, it was stored in the buffer itself, and after that employee 2, and after that employee 3. So now these three objects are converted it into byte streams and they were available at buffer. So now from buffer you are supposed to move it to the output.txt. This is the target place where we want to keep the byte stream. So with the help of this flush method, we can move the content which is available at buffer to the destination file. Okay, so with the help of write method, what you can do, you just simply convert the object into byte stream and you can keep it in a buffer. Okay, by using the flush method, you can move that content which is available at the buffer to the destination, whether it may be a file or it may be a in memory or it may be a database. You can specify the path where you want to keep this byte stream data, right? And after that you just close it. So what happens is it simply closes the buffer itself. The flush method will not close anything, just simply it flushes the information which is available in the buffer to file itself only, right? So that is the reason you are supposed to use the, or you are supposed to call the out.close method for closing that buffer, right? So simply here, because nothing has to print here, so that's why I was printed a message, serialization and deserialization is being successfully executed. So now you can observe you got the same output. That means what it does, all this conversion process has implemented successfully. Okay, I hope you all understood how to create the object into byte stream. Of course, we will see deserialization also very quickly, and then we'll end the session. Sorry for the delay. So this is deserialization, code for deserialization. So for the deserialization, what you have to do, you need to call the method read object, which is available at object input stream. So here I was created an object. So my screen is visible or not? Is it visible to everyone? Any one of you? Make it fast. Okay, thank you. Right. So here I was created object for object input stream in, okay, and from where it is supposed to get the data. Here I need to specify the file output.txt. This is the file which I was previously stored the data stream, okay, or byte stream of the objects which I was serialized before. So that is the reason there we are using file output stream. Here we are using file input stream. File input stream in the sense we are getting the data from it. So that is the reason we are using the file input stream. File output stream, we are storing the data into the file. So that is the reason we are writing the data into the file. So that's why in the serialization code we are using file output stream object. Okay, so now here what it does is the in object will retrieve the information from the out.txt, right? So here I was created another code for it, employee E1 of employee dot in a read object. Okay, so this object will read the information and convert it into employee object. Here I did typecasting for this one, typecasting, right? I say in the similar way, I'll read the three objects from the output.txt, and I was assigned three objects to the E1, E2, E3 respectively. Now I would like to print the name of the objects of E1 and E2 and E3. So let me check. I don't know whether it is executed or not, because the employee class is not present here, which is available in the previous class. Yeah. So because of the reason, the class which we are not defined, employee class. Just a moment, I will. Yeah. So here, don't worry about it. Here, I got an error because the employee class was not defined within the program itself. It takes some time to clear the. Oh, oh. So, right, you see here with this, what we did here itself is we will retrieve the data from the file where we have stored the information, and by using the read object, that byte stream is going to be converted it into object, because the information which you have retrieved from the this particular file is in the form of byte stream. Now you need to convert that byte stream information into the Java object. So for that reason, here we need to call the method read object. Okay, in.read. In is the object of our object input stream class. So with this, we will try to extract the information, and then it will be converted it into object, employee object. Okay, and then we will assign it to the E1. Right? What we are expecting from this program is the names of all these three employees which we have stored previously is need to be displayed. Okay, so some error has occurred. It takes some time. Okay, anyway, don't worry, I'll share these documents with you. You please try at your home how to executing these programs. Okay, I will share executed code to you. Don't worry about it. I will resolve all these errors and I'll share with you. Okay, all right. So any queries? If you have any queries, I'll clear it for 2-3 minutes. Otherwise, I'll end the session. Because there ends the first unit. From next class onwards, we'll start the second unit. That is directly we will enter into the big data. Any queries? Shall I end the session? No response from out of 81. 80 people are there, but nobody is giving response. Whether if you have any queries, you can ask, no issue. Otherwise, you can just drop a message like, no, sir. So that I'll understood that nobody is having any query. Okay, thank you. So I'll end the session now, and we'll meet you in the next class.